Oh, okay, welcome back. So, in the last video, we were trying to figure out how we wanted to merge the Benakat polygon, Subanjariji polygon, and the Martapura polygon. We tried to use a dissolve operation here, which didn't really work for that, but I think that was not how we had to do it. We got to use from the processing toolbox, we had to choose merge vector layers and then go and select those three layers that we wanted to merge. Hit OK and hit run, right? And close. And now we have a merge layer. We don't really see the merge layer. There it is. So we have a merge layer that's kind of merged all these polygons. Excellent, and exactly what we needed. So I'm going to go here. I'm going to export this and save all these features as, I'll just call it 16kha in shapes. And then let's save that as new S3 shapefile, WGS84 CRS. Okay, we're done. So we have these simplified polygons, and now I'm going to go ahead and just update our shapefiles. So we kind of have the potential to succeed here. And it's failing, so I'm hoping that our simplified shapefile structure is going to allow Google Earth Engine to crunch things the way we want it. And all right, so let's go in here and let's start. Just for good practice, I'll restart the kernel in case it needs to reindex something. Let's reload our libraries, reset our shape files, and we're just going to do it now for Banakat. Working on Indonesia Banakat. And there it is working like we see, and it should start populating some files here in this output folder. What it's doing is getting the land cover map for each of those years, and then we'll build some aggregates using that, right? And yeah, let's go there. So strange. Why is it not saving to downloads? Once again, we've got the folder wrong a little bit, but that's okay. It's also doing all the work, so I'm going to just interrupt the kernel here. Just in utils.py, we got to do downloads, land use, land cover, and then set it there. That's where I want it to go. I'll restart again because each time you save an update to the library, you got to restart your kernel. And yeah, I want to run it for at least for Subanjariji and Benakat. So I'll go for 1 and 2. It's Python indexing. So I'll just go till 3. Okay. Let's see. Downloads. Okay, it should start populating here now. There it is. There you see. The files are getting added in as we speak. It's fun to watch these files get generated. Right, it's doing its job. Clearly the polygon has worked. As you can see in GIS analysis, there's so many small judgment calls you have to make, just like in any other analysis. So, but we will succeed, and we will get there. Okay, we're on to Subanjariji now. Great, and it's done. It did it for Benakat and Subanja region. All I now need to do is 401234. Great, 425. And that's right. It's working on the combined core list, 16,000 hectares polygon. This is where the analysis will get really interesting because you'll see multiple different sources starting to point to the same estimates. And it's only then that you can kind of ratify and really take a view on what the estimate should be and shouldn't be. You want ideally estimate generated from field level surveys to match what's coming through your satellite data analysis. It was really about the complexity of the polygons, solving for Benakat and Subanjariji. So that's what Google Earth Engine and its computing on the cloud doesn't really like needing to stitch together so many pieces of data. And that's what is increasing the size of the data it needs to download and work with. But here it's much easier when you have a contiguous boundary. Anyway, so it's also now completed for the 16 kilo hectares. So we've kind of downloaded this now. We have all these files now generated for all of this. Look at how many files we've generated. So now after this, we can start looking at hectareage, right? So basically, let's start with looking at the first one, which was Mozambique here. So this is just a way to corroborate your size of the polygon using the Shapely library, and you find the area in kilohectares should be 175,129.5. Let's see what that was here. Yeah, that's great. 175,129.5. That should be in hectares. Sorry. And similarly here in hectares. Yeah, so we have that right for Mozambique. Now let's check one by one. Let's check the NACAT. It would be, what is one here? One should be Benakat. Yeah. Oh yeah, and for Benakat we ended up drawing 4 polygons. So it's just added up all the 4 polygons here. I like seeing the transpose of that, but what I really want to see is more interested in seeing is the sum of that. That is 10,08373, which is slightly lower. So we evaluated that there. My simplified polygons are saying this because I was slightly liberal and including little more area. I think I'm going to stick with the original estimate. This is where you need to make some discretions, really. So let's now check what we have for Subhanjariji. Again, we have 3. I will introduce the. I want to just calculate the sum of those areas, and that is 5.62, which is much better because it's expected to be slightly less than this because we clipped off some areas. So that's fine. And let's then look at Martapura. And it is 0.319 kilohectares, or it's 319 hectares. Does this make sense? Yeah, it's great. It's just there. It's 309 versus 319. I think I'll just write in 309, 310. It looks good. I think we can lose these estimates here. We don't need them. And okay, and let's look at the total area, which would be number 4. 16 kilohectares, exactly what we wanted to see. Number that we like a lot. So these two look pretty close, but I'll retain the first one because it perfectly adds up. So we're happy. It looks exactly like what we want. Right, so we're happy with the hectareages, and we have an alternative way to estimate if we need it. Okay, generate the class table here. What are we looking for here? We want the current land cover type. So we're going to look at the 2020 land cover maps. And we're going to see what the current land cover type for each was. So first we're looking at Mozambique. It's showing B and K because I put my counter at 1. Right. This is the land cover map for Mozambique. Right. So what I'm most interested in copying over is this part. So let's keep that. Let's go to one of our old ones and bring this in. Great. Okay, looks like we're gonna need to do some percentage computations. We have all of this going in kilohectares. I just want to confirm. Yeah, it should be. Nope. What we have going here are percentages. This is 98%, and the sum of all this seems to add up to the remaining 2%. So what we actually have here is land cover classes expressed as percentages. So we're going to need a system to go from percentages to actual areas. Let's start a new page here just to create a calculator for that. So here we are. Let's go there. Let's make it a percent. And then we also know the total area for Mozambique in hectares. We want to express this in kilohectares. All right. So we have that. So we'll just go that times that. And all these estimates we're building here are going to be in hectares. We need to add a dollar. Pull that down. We have it in hectares. That is great. The other thing we'll just do is we'll just organize this. We'll just copy it, paste special values, and order this in descending order of their percentages. As you can see, some parts of this area are actually water bodies, so they're not relevant to our reforestation efforts. There's only a tiny bit that's already forest land cover. So mostly you're looking at reforestation, savannas, shrublands, semi-shrublands, and that definitely checks out. So right, so now we've just rearranged that by order, and here I'm gonna make those estimates into kilo hectares, and unsure I only retain 2 decimal points. I will paste values, and I will also do the same for this. Right. Yeah. And I will delete this. Great. And now we bring this into here perhaps. Yeah. Have it. What is that size? I'm gonna guess the size of this is like 7 or something. Wait. So we have it 7. Let's just get it all centered. Takes so much work to do all of this, but it's the best way to present the data, I feel. Okay, here we are. Then we need to talk about what is the percentage of total forest, right? And we know that there is only this one land cover type here. So yeah, it's just 0.15%. That's all it was. And this last summary field, I just keep it of this color. How many kilo hectares was existing forest? It was only 0.25. This is clearly more of an ARR activities of reforestation rather than RED plus. RED plus is when you already have reasonable forest cover and you don't want to, you're trying to prevent it from being deforested. So great, we created this piece for Mozambique. And now we're going to start doing the same for Indonesia. So let's bring this exhibit here, and we're going to mix this up now for all three. Okay, interesting. We have 4 polygons within here, right? And all of them are slightly different. So one polygon has 7%, 1%, 1%, but mostly they're like, between 87 and 92% woody savannas. Interesting. So I'm just thinking if the best thing we should be doing, because we don't really necessarily want to look at this. So I'm just going to take so again, judgment call here. You have to really construct this exhibit a little painstakingly, but it's worth it. Okay, here we are. So I think I'm just going to take the average here. You wouldn't be too starting to work with the averages, I feel. So take the percentages from there, copy, paste special values, bring that in here. Now we're working purely for Benakat, right? Forest. Okay, so we got that. We can now go here, take the area for Benakat in hectares. Here we'll just keep it entirely in hectares because of the scale. All right. Great. So we got that in there. Just convert it to a number format with only 2 decimal places. That's fine. Okay, great. Great. So now we can bring, okay, we have only 4 land cover categories here as well. bring it here, don't need the bolts. We center align that. Okay, great. So now it asks what is the percentage forest, and we can estimate that 6.46% forest was, and that was the hectareage. This hectare, so we don't misinterpret it. We know this is Banaka. So now we're going to start adding the other ones to it. Right, so now let's look at Subanjariji. Thankfully, we have similar land cover types going in here. Woody savannas, broadly first, and savannas are the top three. Great, so this allows us to create a good looking visual where we can have one table 27 and 72%. That looks great. We need to get the total area for Subanjariji, which we know is this. And then we do that times that with a dollar sign. We put that down to generate the area in hectares. These special values. You kind of drag that in there and try to kill that. Great. So broadly first. Excellent. So now we need to create space for we're dealing with similar structures here, which allows us to do something like this. You can make a table there for Banaka and then get similar structure for the other two, which are Subanjariji and Martapura. We'll add a total at the end as well. Okay. Now we're in a position to update. We know that this is 0% for Subanjariji, but we know these numbers are something we can update for. Nope, we forgot to update the land cover categories last time for here. Sorry. We are doing something funny here. We were supposed to do all of this for Indonesia actually. Sorry. Well, we can work that out. Jeez. This was what was needed for Mozambique, and this is actually what we need going in here for an Just goes back here to Indonesia. Okay. Now we're in a position to update this for Subanjariji. Great, so it looks slightly different. Where evergreen broadleaf forest is the main category for. So it already looks reasonably reforested. There could even be some red plus potential. Interesting. Okay, great. So next we need to update the area for Martapura and total. Just want to do a quick check on time. I think it's good time to stop. Let's continue area for Martapura total and all the other computations in